Hi guys, today we're going to be attempting the following sum, and it has to do with Euclidean geometry. So let's read the required. It says, in the diagram below, points R, P, A, and Q and T all lie on a circle. So that just means that they touch the circumference of the circle. This is where the important part comes in. They say RA bisects. Okay, it bisects. Now bisect means that it's in equal halves. So it bisects angle R. So that means angle R2 and angle R1 are the same thing. So angle R1 is equal to angle R2, okay? And the reason was given. And then they say AB is equal to AQ. So AB is equal to AQ, which then means because of an isosceles triangle that Q3 and B are the same angle. So therefore, Q3 is equal to angle B, and this is op angles equal sides. So I'm already deciphering it before I even look at the required. They then say to us that RA and TQ are produced to meet at B. So that's not as important, just saying that it could possibly mean that there is a large triangle between RA and TQ, so it would have been RA and they'll meet at B. Okay, so we would have had that sort of triangle. Now it says we need to prove. Now proofs are a little bit more difficult. Okay, so let's get into it. They say we need to prove that AQ bisects PQ. So AQ, okay, they're telling us that we need to go and look. Let's first get rid of this just for now. Okay, we need to go and see that AQ bisects the angle PQB. Okay, so what they're saying in essence, remember what the principle was with bisect, that the angle that it bisects, those two need to be the same. So our required to prove, I always write something for myself so I know what I need to do. So my required to prove is I have to prove that Q2 is equal to angle Q3. And then I'll be able to prove that it bisects. Because remember, if it bisects, it means that those angles have to be the same. So now we go and work through it. Okay, so first things first, I can see that angle R2 is equal to angle Q2. And if we just have a quick look-see, that's because of what we know is angles in same segment. Okay, that's how we know that those two are the same. So we now go further. So R2 is equal to Q2, and I'm just going to give it a variable x, just to make my life a bit easier. Okay, and the reason for this is angles in same segment. Okay, then from there, we then say to ourselves, okay, now how can I prove that perhaps Q3 is equal to that? So this is where it then takes some brain power. So what do we know about the exterior angle of a cyclic quad? We know that the exterior angle of a cyclic quad, which in this case is here, okay, has to be equal to the opposite interior angle of the cyclic quad. So we know that angle R1 plus angle R2 is equal to angle Q2 plus angle Q3 because of exterior angle of a cyclic quad. Now, we have just proven previously that angle R1 is equal to angle R2, which means that they have to be x, and remember that was given because the line bisects. So that then means that R1 is that. So the whole angle R1 plus angle R2 is equal to 2x. And therefore, we know that angle Q2 plus angle Q3 has to be equal to 2x, which therefore means that angle Q3 has to be equal to x, okay? Because we've already proven that Q2 was x. And the only way I can get 2x is if the corresponding one is x as well. And therefore, we have just proven that AQ bisects PQB. And your reasoning for this, okay, was because of the fact that angle Q2 is equal to angle Q3, which is equal to x. And because those two angles were the same, we therefore know that AQ bisects PQB. Okay, so now I'm just going to give all of these variables here just so that we can continue. So we've just proven A. Now, since we know it bisects, we know that those two angles are the same, so everything so far is correct. Okay, I'm just quickly going to erase these. Okay, so we've just done 8.1. Now let's move on to 8.2. So in 8.2, we have to prove that TR, okay, that TR is equal to TB. So TR is the same as TB. And the way we can do this is using our isos principles, okay? Because remember, if we look here, we can see that there is a triangle. So if we can prove that that and that are the same, we prove what is called an isos triangle. And what do we know about isos triangles? Their opposite sides are equal. Okay, so now we know that we have to require to prove is technically op angles equal sides. But remember, it's the converse of that because it hasn't been provided to us yet. When you prove something, you can write the converse of it. Okay, so now we're going to go about and do it. So we've already proven R1, we've proven Q2 and Q3, and R2 as well. But remember, in this triangle below here, we have already figured out that Q3 and B have to be the same. So angle Q3 is equal to angle B, which we are now going to label X. And remember, the reason for this, they've given us that those opposite sides were equal. So therefore, it's op angles equal sides. Okay, that one wasn't too bad. And now look, angle R1 is equal to angle B, which is X, and your reason is proven. Therefore, TR must be equal to TB because of converse of op angles equal sides. The other way that people say this is you can say op sides equal angles. Okay, so that would be the second version that you could have used. So now we've proven that that side and this whole side are the same. Every single time I've done something or solved for something, do you see that I've now written it on my diagram? I would please ask that you do the same, because when you look at your diagram, you want to have all your information present so you know what you still need to look for or what information you've already solved for that you can use again so you don't have to solve for it all over again. Okay, so now we're going to deal with angle P equaling TRP. Okay, so let's quickly erase that. We're now going to be dealing with 8.3. They are asking for P, okay, angle P, to be the same as TRP. So TRP, that's this whole angle here. Okay, so we now know that this is 2x just from what we've deciphered. Okay, and we somehow need to prove that that angle there is also 2x. Okay, so this is where the fun part comes. Okay, so if we have a look at the diagram, we know that over here we have angles in same segment. So if we can prove that angle A1 is equal to 2x, we can therefore prove that angle A1 is equal to angle P, which would then be 2x. So our requirement is to find out the value of A1. Now that's really simple. Remember the concept of the exterior angle of a triangle. Okay, if not, you'll learn it now. Okay, the rule for an exterior angle of a triangle is that it is equal to the opposite two interior angles. So what I always do is if I want to find the value of this one, I just hop to the inside and I go to the opposite two angles and add them together. So if we look at our triangle, we're going to be here, we're going to hop inside and then go to the opposite two angles. So we know that angle A1 is equal to angle Q3 plus angle B. And our reasoning for this is exterior angle of a triangle. Now from here, we then just go and fill in our blanks. We've already given them values, okay? Which means that A1 is equal to 2x. Now I know that that value there is 2x. So now we can do angles in same segment. Angle P equals angle A1, which equals 2x. And this reason is angles in same segment. Okay. Then once we've written that down, we can then go and label that as 2x. Now, we haven't quite done it yet. We've only done what was required. So now we have to say that angle P is equal to angle and label it the way they've labeled it. And your reasoning would just be proven. Okay, and there you go. We solve for every single angle. If you'd like to find more videos on this section, just click on the link below and it should take you to videos that further on this section. Thank you so much for watching, and if you'd like more videos, please like and subscribe.